Good afternoon.
Good afternoon.
So let's ask you a question, Hannah, to start us off. So I've got your letter mostly done. I've just got a few more minutes left to put finishing touches. Do you need that today or tomorrow morning?
Today would be better, but I
Okay.
can maybe like early tomorrow morning, like before 8 probably.
Okay. I'll just do it. Finish it up.
Okay, that works.
That's what I wanted to know. So okay. Let's see. All right. Let's. Is Chloe here today, Skylar?
Yeah, she's here.
Okay.
She'll be right back.
Exactly.
Okay, and looks like everybody's there in St. John's.
Yep.
All right. Awesome. Okay. All right. So just a couple of comments actually about the chapter 8 test, and maybe. Well, anyway, and maybe an 8-8 quiz. So a question came up about, so I said I wasn't going to put the diverging questions on there, and I left them on there. I actually saw it, and I thought, well, I'll take them off. And then I realized that, you get 2 attempts and your highest score. And so even if you got it wrong, you could fix it. And so I thought that was kind of an easy point. So that's why I left those on. I actually wasn't trying to make life difficult for you. I was actually trying to have your test scores be a little higher, is why I left those on. So that's the one thing about giving you the highest score of the 2 is it kind of true false or 2 type questions, two answer questions are kind of a gimme in a way. But anyway, the other thing is that, and I know there's a couple of you that still want to take the second attempt, and so I don't want to be too specific, but there is actually one of the fill in the blank questions on the chapter 8 test where, depending on how you put in your answer, it didn't accept it as the correct answer. And so I just want you to know that if you're like, oh, I'm sure I got that one right, you probably did. Okay. So just know that, maybe after tomorrow, I'm going to go back through while it's still open and it won't let me change it. But once it's closed and people are done taking it, then I can go back in and change the key and it will regrade it. Okay. And so that's what I'm going to do. But it won't let me do that sort of midstream. So anyway, so you might look at your chapter 8 score and it might go up. Okay. Is kind of what I'm saying. All right. So let's see, with those things out of the way, so let me tell you what the plan. So for today, the main thing is to practice or review for the midterm. So on Wednesday and Thursday during class time, we're going to take the midterm, and the midterm is going to cover chapters 7 and 8. And the big difference is that there's only one attempt allowed, and there's a 60-minute time limit for each part. And so there's 10 questions on each part. So let's talk about and then if you don't have enough questions to fill the period, I'm ready to start in on chapter 9. But one question though, before we even think about that, is did I send you guys? Do you have the guided notes for chapter 9? Did I send those? Yeah, I didn't think I did because I was kind of focused mainly on the midterm. So anyway, I'll put that down. Chapter 9. Okay. So, how about, does anyone have questions for me? Any question for me?
Yes. So, in section 8.6, there was the extra credit problems,
Oh, yes.
and on the last one in that,
Okay.
it says
It
this.
says to substitute pi halves minus u for x, and yeah, and like subtract them from and add the new and old integrals, and I guess we're just unsure of like what that means exactly.
Okay. All right. So let's see. That's 8.6, the extra credit. Basically, what it's asking you to do is to change the argument of the trig function. Okay, so now substitute x equals pi halves minus u. Okay, I'm not sure what the u is, but I think what they're wanting you to do is okay. Let me see if I can. Okay. Yeah, it's. I didn't realize how confusingly written that question was. So let me just. So what they're wanting you to do is to change the argument. Instead of having x, have it be pi halves minus x. Okay. Let's see if I can. Well. Okay. So when let me just. Okay. Well, let's just go back to Wolfram Alpha. Okay, so like here when we integrate, so if we want to change whatever, so we're going to integrate, this is sine, so let n be 1, so let's just do it for 1. So we just have the sine, and we could even leave the 1 in there. Okay, and so what it's saying for that part of it is to change x to x pi halves minus x. So pi, let's see. So pi halves minus x. Let's see, is it going to take that? Okay, there's the pi. Oops, okay. So put the pi here. So pi halves minus x, and then that whole denominator. And then everywhere you have an x, put in pi halves minus x. And then do it for n equals 1 through 7. And then it will, see, I haven't put in the denominator here, but once you set it up the first time, then all you'll have to do is just change the n each time. And then you'll just try to look and see if there's a pattern or something like that. And then what you can either print it out and send it to me, or do a screenshot, or whatever you want to do. Okay. So that I think is what it's asking you to do, is change the argument to x to pi halves minus x. So then you get, you can start doing fairly complicated problems using the computer algebra system. Okay. So you see here, like, for example, okay, so I just did the numerator. So the sine of pi halves minus x, the integral of that is sine x. Because the pi halves minus x, that's the same thing as the cosine of x, and the integral of cosine takes you back to sine. So it's trying to help you see different relationships like that. That's the whole point. And so then by changing the n's, looking at the denominators, you can, you try to look for different patterns. So that's really what I'm hoping you'll get out of that. Plus, I'm hoping that, like, you'll learn how to use this extended keyboard and kind of play around with it, and that's kind of what I'm hoping for. But it is kind of poorly worded there. So, okay, does that answer, or do you need some more direction on that, do you think? We need to keep going on that problem?
No, we're good. Thank you.
Okay, all right. You're welcome. Okay, anything else? Or what else? I should say it that way.
Can I retake my second attempt for the Chapter 8 test tomorrow at 12:30?
Sure.
And we also need to take our second attempt.
All right. So Chloe, what time did you want yours?
12:30, please.
Let's do it 12:30. And St. John's, what time did you guys want?
Me and David want it from 1:30 or 1:50 to 2:50, and Aiden wants his from
7:50 to 8:50.
Okay, so Aiden. Joey and David at 1:50. Okay? So that's all tomorrow. All right? All right, so Aiden, I've got to do yours before I leave today. So I won't come in the morning before 7:50, so. Okay? All right. So, what concepts do you want me to go over?
Yeah, can we do 8.3 a little bit?
Sure. So, if you look in the book, are there any of those problems in particular you'd like to do, or you want me to just pick one at random, or?
Yeah, like number 5 maybe.
Okay. Okay. All right. So for number 5, we have the integral of sine cubed x dx. Okay, so this is where you had your case 1 and case 2 and case 3 stuff, and so basically, sorry. So when you have an odd power, what you do is you peel that one off. So I'm going to have this be sine squared x times sine x dx. And then I'm going to replace sine squared, put that in terms of cosine squared. So that's 1 minus cosine squared x times sine x dx. Okay, so now you've peeled off one of the odd ones, and so then now the cosine you want to pick to be u. Okay, so let's let u equal cosine x. Okay, then du would be, the derivative cosine is negative sine x. So dx. So what I need is a negative inside here. So I need a negative to go with that, and so I'll put a negative out front. And so now my new integral will become the negative of the integral of 1 minus u squared. And then the negative sine x dx, that's du. And so now this is going to be the negative of, so the integral of 1 is u minus u cubed over 3 plus c. And so then I substitute back what u was. Oh, let's see, it was minus a negative, so that's going to be plus. So then I plug in cosine, so that's going to be negative cosine x plus cosine cubed x over 3 plus c. All right. All right, so questions on that? All right, how about another question then? And you can pick another one from the same section if you want to, keep practicing that, or if you want to go to a different section.
27.
27? Okay. Let's see here. Okay, so all right, so I'm not seeing well, this to get this out of the radical, what I'm going to need to do is multiply by its conjugate. Okay, that's kind of what I'm saying here. Wait, I forgot the dx here. Okay, so I'm going to multiply numerator and denominator by radical 1 plus cosine x. Okay, and because what that will do, okay, so let's, so I'm not going to multiply out the top. I'm going to just leave it as sine squared x times radical 1 plus cosine x dx. So in the denominator, when I multiply this out, it's going to give me 1 minus cosine squared x. The middle terms will drop out. Well, 1 minus cosine squared x is going to be sine squared x. Okay. So I'm going to substitute in here sine squared x. And then the square root of sine squared is just going to be sine x. And so now the sine will cancel with the sine squared. And so then I'll get sine x times 1 plus cosine x dx. All right. So then I can let what's underneath the radical now, I can pick that to be my u. And so then my du, the derivative of cosine is negative sine again. So I need a negative in here and out front. So now I do the u substitution. And so I'm going to get, so 1 plus cosine x, that's u. So that's u to the 1/2. And then negative sine x dx is the du. And then I have the negative in front. So I'm going to go ahead and change the limits of integration here. So let's see. So cosine of pi halves is 0. So 1 plus 0 is 1. Cosine of pi thirds is 1/2. Let's see. No. Yeah, 1/2. So 1 plus a half, so that's 3/2. And so now the integral of u to the 1/2 is going to be u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. And now I'm going to switch the limits of integration and take care of that negative. So I'm going to put the 3/2 up here and the 1 down here. And so that's going to give me 2/3 times 3/2 to the 3/2 power minus 2/3 times 1 to the 3/2 power. All right, so 1 to the 3/2 power is still going to be 1. So this back part is going to be 2/3. I don't see any way to simplify this here. Let's see, so 2/3. See, I could cube it, but then square root's not going to happen. So I'm going to just leave it like this, 3/2 to the 3/2 power. Or a lot of 3/2, 2/3. So, so then you would probably want to put that in a calculator and get a decimal. Whoops, sorry. Okay, so let's see, 2/3 times 3/2 raised to the 3/2 minus 2/3. Okay. And then let's, since we have a definite integral, anytime we have a definite integral, we can always put it in the calculator to begin with and check and make sure that we're doing this right. So let's do that. So math, integral, so from pi thirds to pi halves. Okay. So let's see, we have a fraction. So I'm going to do a second math. No. Let's see, it's just math fraction. So that forces a fraction. So we don't have to have that second set of parentheses. So sine squared x. So that's going to be sine of x. Close off the x, close off the sine squared, divided by the square root of 1 minus cosine x. Close off the argument, arrow out of the radical, and go to the dx. Okay, and here's the moment of truth. Bam. So that means we didn't actually make a mistake in all that mess. Now, let's just see if there is an easy fraction. If we do math, answer is a fraction, then so there isn't really a fraction there we could do. Oops. Now, so, whenever I have a problem like this on like a test, okay, what I will do is decide which way am I better at getting the answer quicker, okay? And whether doing it by hand or doing it by the calculator, okay? And on a test or quiz, midterm, I would do it that way. And then after I worked through the whole test, then I would go back and do it the second way, okay? So make sure you finish the thing first, but then I would go back and double check everything. If you know 2 ways to do it the second way. But I wouldn't do what I just did there, where I worked through the whole thing 2 different ways. I wouldn't do that until after I'd worked through the test. Okay? Oops. All right, any questions on that? All right, another question perhaps.
Can we move to chapter 7.6?
Okay, 7.6. Oops. All right. So what number? Or
83.
83. Let's see what it's 83. Oh, that's it. All right. So here we have the integral of inverse sine of x squared over radical 1 minus x squared. All right. So it says let u be inverse sine of x. Why would we do that?
Because the square root of 1 minus x squared is the derivative of sine inverse x.
That is correct. So our du then is the rest of it. Okay. So then when we do our u substitution, we just get the integral of u squared du, which is then u cubed over 3 plus c, and then you replace what u was, so it's back to inverse sine of x. So 1/3 inverse sine of x plus c. All right, any questions on this one? All right, how about another question?
Could we do question 89?
On the same page?
Yep.
Okay. I think you just looked at the longest problem and on the whole thing and said, let's just do that. But we'll see.
No, it had more to do with I don't know how to do ones like that.
Okay. Well, we'll see. So, okay. So here's what my initial feeling is we have two issues going on here. We have a radical x and we have the inverse tangent. Okay? So those are kind of like two separate things to deal with here. So I'm a little bit unsure, but the best thing to do is just try something. So what I'm thinking we might have to do is do like a double substitution, like a U substitution to get rid of the radical, and then another substitution, like we'll call it a V substitution, to get rid of the inverse tangent. That's kind of what I'm thinking. All right, so let's just try it. So here, if I let U, let's get rid of the radical here. So let U be radical x, okay, which is x to the 1/2. So then du would be 1/2 x to the minus 1/2 dx, which is the same thing as 1/2 radical x dx. See, that is going to get rid of this radical x right here. Okay? So let's put it in terms of U then. Okay, so then that would be, okay, so I need a 2 in front and a 2 down here. So then that would give me 2 times du over, okay, so all of that is du. So then if u is radical x, then this is going to be u squared plus 1 times the inverse tangent of u squared plus 9. Okay? All right, so now let's do a second substitution. Let's let v equal the inverse tangent of u plus, the inverse tangent of u. Okay, then what's dv? What's the derivative of inverse tangent of u?
1 divided by 1 plus u squared du dx.
Okay? So now putting it in terms of v, see then the du over u squared plus 1, all that's just going to be my dv. So I'm going to have 2 times the integral. So all that's dv. And then I'm going to have the inverse tangent. No, this is going to be v squared plus 9. Let's see. No. Let's do it this way. Wait. Okay, if v inverse tangent, I'm running out of time here. No, okay, all right, fine. Okay, okay, so now this is going to be, so the integral of v squared plus 9, that's 2 times the inverse tangent of v over 3. Is that right? And then we actually have a 1/3, so it's going to be 2/3. And so now we plug in what v is. I would never give you one like this. I mean, except for like, you know, for fun. Okay, so what was v again? Inverse tangent of u. Okay, and then finally, what was u again? Radical x. So then I think my final answer is the inverse tangent of the inverse tangent of the square root of x over 3 plus c. So Hannah, was it you're just washing your hands of this whole deal, or were you clapping there? I wasn't quite sure.
I probably should be clapping after you just did that.
And that's looking at it cold. I mean, I didn't think my brain was even operating at that level yet. So anyway, well, unless there's a quick question, I think that's going to be it.
Yeah, I was actually going to ask you, do you mind if I take my chapter 8 test, second attempt tomorrow at 10?
Okay, so let me make that note here. Okay, so chapter 8, second attempt. So Chloe at 12:30, St. John, Joey and David at 1:50, Aiden at 7:50, and Hannah at what time?
10.
At 10. Okay, is that it? Well, good luck, you guys, and have a safe spring break. Email me if you have any questions or if you need anything open. Let me know. I'll still be around, but I won't see you until March 23rd. So you guys have a great one.